Hello, this is Coach Cerise, and today I would like to talk to you about the learning target. I can conduct and explain the hypothesis testing of a one sample proportion using the normal model. In 2012, 38% of 18 to 24-year-olds voted. I found this on the website childtrends.org. Imagine that an organization would like to increase this percentage by creating a commercial and playing the commercial at schools, colleges, and universities for months before the election. After the election, we randomly select 18 to 24-year-olds from the schools, colleges, and universities where the commercial's played, to survey and discover that from the sample of 3,722 people between 18 and 24 years old, that 41% of them voted. For the sake of this example, for this learning target, let's assume the commercial is the only variable that we're going to be considered. The question: conduct a hypothesis test for a one sample proportion to determine if there is evidence that the commercial increased the proportion of 18 to 24-year-olds that voted. To begin our hypothesis test, first you must check assumptions and conditions. The first assumption is independence. Was everyone in the survey independent? And we will say yes. The people in the survey were from different families, different schools, different ages. Was everyone in the survey selected randomly? We will say yes. The problem tells us that everyone was randomly selected. Was the sample size less than 10% of the population of 18 to 24-year-olds? Certainly 3,722 people will be less than 10% of all 18 to 24-year-olds in the country. If necessary, we could probably do some research and find out exactly what is the population of 18 to 24-year-olds in the country. We also have our success and failure condition. Is the sample size times the proportion of 18 to 24-year-olds that voted in our model greater than or equal to 10? Is the sample size times the proportion of 24-year-olds that did not vote in our model greater than or equal to 10? For our model, we will assume the proportion is the same as the 2012 election, which is 38%. So therefore, is the proportion who voted, 38%, times the sample size greater than or equal to 10? And the answer is yes. Is the proportion who did not vote, that would be the Q, times the sample size greater than or equal to 10? And the answer would be yes. Since the assumptions and conditions are met, we can continue to carry out a hypothesis testing. Our hypothesis is what we assume. In this case, we're going to assume that the proportion of students between 18 and 24-year-olds that voted was 38%. We're looking to see if there was an increase in this value. So our alternative hypothesis will be greater than 0.38. 0.38 will be our center of our model. From the center of our model, we will go 3 standard deviations to the right and 3 standard deviations to the left. In order to find our standard deviation, we will use the formula. The standard deviation for the sampling is going to be the square root of P naught Q naught divided by N. P naught and Q naught are from our null hypothesis. So the standard deviation for the sampling is going to be 0.38 times 0.62 divided by the sample size. And we said that we had a sample size of 3,722. Doing this mathematics, we have a standard deviation of 0.00795, which we will approximate to 0.008. Now that we know our standard deviation, we can take the center of our model and we will add 0.008. So one standard deviation, two standard deviations, three standard deviations. Going standard deviations to our left, we have now created our model. Just by looking at our model and thinking about our sampling proportion, which is our p hat, that was equal to 0.41. We can already see that 0.41 is going to be way to the right. More than 3 standard deviations, that is an unusual value to get from a sample when we're assuming that the proportion of 18 to 24-year-olds who vote is 38%. So I can already see that my sample is going to give me evidence to reject the null and support the evidence that it has increased. We're going to go ahead and continue on with the model. I also want students to understand that we could also have used the standard model, where instead of using the actual data value, we use the z-scores. So this is the model with z-scores. This is the model with actual data. We're going to go ahead and convert our sample statistic, which is when we take our sampling proportion minus the proportion on null hypothesis and divide it by the standard deviation. And this is how we get a z-score. The z-score tells us how many standard deviations a value is from the center from 0. So if we take our 0.41 minus 0.38 divided by our 0.008, we have 3.75, which is more than 3 standard deviations from the mean, which would be considered very unusual. So we have created our model. We have our sampling statistic. Now what we like to do is find our p-value. A p-value is the probability of getting our observation given that the null is true. So given that the true proportion of 18 to 24-year-olds is assumed to be 38%, and our sampling is at 41%, this area right here to the right is going to be the p-value. To calculate this, we can do a norm CDF, 0.41, something way to the right, say 100%, with our assumed proportion and our standard deviation. this value comes out to be 0.000088, which is approximately 0. So the probability of us obtaining a sample of 41% of 18 to 24-year-olds voting, given that the true proportion of 38%, would happen nearly never, 0 times. So since this is so unusual, and we did meet all the conditions and assumptions, that would give us reason to reject the null hypothesis. We would reject this hypothesis that the proportion is 38%, and we would say that we have evidence to support that the proportion of 18 to 24-year-olds who have voted has increased. Evidence to support an increase in the proportion of 18 to 24-year-olds that vote. If we were given an alpha level, then we would have compared the alpha level and the p-value. If the p-value is less than or equal to the alpha level, we reject the null hypothesis. If the p-value is greater than the alpha level, we do not reject the null hypothesis, or we may say fail to reject. We can also find the z-score. We can also use the z-score to find the p-value. If you remember, our z-score was 0.375. So if we have 375, this is with the standard normal would be 0. This area under the curve would be our p-value. We go far to the right of 10. And in this case, we got 0.0000884, which is close to 0. To answer the question, conduct the hypothesis test for a one-sample proportion to determine if there is evidence that the commercial increased the proportion of 18 to 24-year-olds that voted. We would go ahead and say, yes, we have evidence that the commercial increased the proportion of 18 to 24-year-olds that voted. Hope this is helpful, and you can rewind it, play it again, look through the different information. Always feel free to send me an email or come and see me during A&P, and we can practice more problems. Have a good day.